Hello! Today I'm talking about one of the most fascinating and game-changing concepts in blockchain technology, smart contracts. I'll break down what smart contracts are, how they work, which blockchain ecosystems support them, and the tools you can use to start building them. Let's dive in. First, let's define smart contracts. Simply put, a smart contract is a self-executing program stored on a blockchain. It automatically enforces the terms of an agreement once certain conditions are met. Think of it like a train ticket machine. You choose your destination, pay, and it prints your ticket. No human is needed to mediate this transaction. Smart contracts work similarly. They take input like money or data, process it according to the predefined rules, like checking if the amount is correct, and produce the output, like transferring ownership of an asset or providing access to a service. This makes them perfect for automating trustless interactions, where all parties can rely on the code to execute correctly. Now, many people associate smart contracts with Ethereum, and for a good reason. It was the first platform to make them mainstream. But did you know that many of the blockchains also support smart contracts? Each of these ecosystems has its own unique strength, programming languages, and developer tools, so let's explore them together. First, there's Ethereum. It introduced the concept of smart contracts to the world and remains the most popular platform. It uses Solidity as its primary programming language, with Viper as an alternative. Developers often use frameworks like Hardhat or Truffle to make building and testing smart contracts easier. Next, we have Solana, known for its high speed and low costs. Solana smart contracts are written in Rust, C or C++, and are typically built using the Anchor framework, which simplifies development. Polkadot is another exciting ecosystem designed for interoperability between blockchains. Smart contracts on Polkadot's substrate framework are written in Rust using the Ink library. Then there's Binance Smart Chain, or BSC, which is EVM compatible. That means you can use the same tools and languages as Ethereum, like Solidity and frameworks such as Hardhat. Cardano focuses on formal verification for security. Its smart contracts are written in Plutus, which is based on Haskell, and developers can practice using the Plutus playground. Avalanche is known for its subnet and scalability, using Solidity for smart contracts. Near Protocol offers simplicity and accessibility using Rust and assembly script. Sui and Aptos, two newer ecosystems, introduce a novel programming language called Move, whose syntax and principles are influenced by Rustlang and specifically designed for safety and resource management in blockchain applications. Move focuses on secure and efficient asset management, making it developer-friendly while also ensuring high throughput and scalability. We should also mention Elrond Multiversix, which supports high-performance smart contracts written in Rust or Arwen assembly. It's ideal for applications requiring speed and scalability like DeFi or NFTs. Lastly, the Cosmos ecosystem brings something unique with its modular approach. Chains built with the Cosmos SDK can enable smart contracts through CosmWasm, allowing developers to write them in Rust. Additionally, the Inter-Blockchain Communication (IBC) protocol relies heavily on Rust-based contracts for seamless interoperability between Cosmos chains like Osmosis, Juno, and Terra 2.0. Starting as a developer is easier than you think. For beginners, Ethereum is often the go-to because of its rich ecosystem of tutorials and tools. If you prefer high performance and like Rust-Lang, Solana is another great choice. Here's a simple roadmap. First of all, choose a blockchain ecosystem that aligns with your goals. Second, learn its primary programming language. If you want to explore the most widely used and beginner-friendly path, this would be Solidity. However, if you're eager to learn a modern and versatile language with a broader application scope, Rust is an excellent choice, especially for high-performance or innovative ecosystems. Third, explore frameworks to simplify development. And fourth, practice by building small projects like a token or simple marketplace. When developing smart contracts, keep these best practices in mind. Break down your logic into smaller reusable functions. Test extensively. Optimize your code for efficiency, especially on Ethereum where gas fees can be high. Regularly audit your contracts, either yourself or through a third-party security firm. Keep up with blockchain updates and new vulnerabilities. Smart contracts are the backbone of Web3, enabling trustless automated interactions across a decentralized network. Whether you're exploring Ethereum, Solana, Polkadot, Cosmos, or any other ecosystem, each offers unique opportunities to develop innovative applications. If you're a developer who's new to blockchain, I encourage you to pick an ecosystem, experiment with the tools, and create something amazing. Blockchain technology is still evolving, and there's so much potential for you to make an impact. I hope this video was useful for you. Bye!